Number 3. The length of a rectangle is decreasing at a rate of 2 centimeters per second. So the change in the length with respect to time is 2 centimeters per second. While the width is increasing, again, that was decreasing, so that should have been a negative 2. The width is increasing, so dw dt is positive 2 centimeters per second. When the length is 12 centimeters and the width is 5 centimeters. We have a two-parter here. We want to find the rate of change of the perimeter, dp dt, for part A. And then for part B, we want to find the rate of change of the area. So let's look at this. We've got a rectangle. This is our length, and this is our width. For part A, we want to find dp dt, the change in perimeter with respect to time. So perimeter of this, well, perimeter is just when we add up all the sides. So we're going to have 2 lengths and 2 widths. So it's going to be 2L plus 2W. I want you to go ahead and take 30 seconds to figure this one out. Figure out what dp dt is. All right, I'll give you 45 seconds. Shouldn't take too long. Ten seconds. All right, let's go ahead and take a look. For this one, you should get a rate of change of 0. Perimeter is not changing because at this time, since the length is changing, getting smaller by 2 centimeters per second, width is getting bigger by 2 centimeters per second, they basically cancel each other out. Now, let's look at part B, the rate of change of the area. Do you think that's still going to happen as these are changing? Is the area, change in area, going to be 0 as well? Well, figure that out. Think about it. But we're going to go ahead and find out for sure. For part B, area of a rectangle is just length times width. Now, we haven't had to deal with this in these types of problems yet. We've kind of avoided it up until now, but in this case, we're going to have to use product rule. We've got dl dt, dw dt, we got lw. We can take care of this. We have all the variables that we need. We don't have to substitute anything in like the volume or the cone problems. So here we just go ahead and take the derivative of both sides. We get dA dt equals, here we have to use product rule. Derivative of the first one would be dl dt times the regular second function plus regular first function times the derivative of the second one, so dw dt. We can go ahead and substitute these in. dl dt we know is -2, width is 5, plus L is 12, times dw dt, which we know is +2. So -10 plus 24. Our change in area with respect to time is 14 centimeters squared per second.